Now we are going to see what is the uh, effect of negative feedback on input resistance. So it is going to be, we are going to see about effect of negative feedback on input resistance and effect of negative feedback on output resistance. So we are going to study about these two things. So you know that input side you have the mixing network, in output side you have the sampling network. Correct. So that is how the negative feedback is the feedback circuit is designed, right? So input side you will have a mixing network, output side we have the sampling network. So if the mixing is going to be, series mixing, you know, when you are going to mix it in series way, you know, in series the input impedance is going to increase. So when I'm going to use a series mixing network, my input impedance is going to increase, and it is given by RIF equal to RI into 1 plus A beta, or I can say it is RI into D. When I'm going to use series mixing at the input side, output side, whatever I use, I don't bother. See, this current series, voltage series feedback and all, we didn't study because of that only I'm saying in general. Because this is a separate topic which comes in second half. Just for understanding this two property, I'm just saying, remember these 2 points. In the input side, since you have the mixing network, if the mixing network is of series mixing, then the input impedance will increase because series all the resistance values get added. So RIF equal to RI into 1 plus A beta or RI into D. If I'm going to use shunt mixing at the input side, the input resistance will decrease, and that is given by RIF equal to RI divided by 1 plus A beta or RI by D. Only two conditions, you can clearly understand this. If I'm going to use series mixing at the input side, it is going to increase my input resistance. If I'm going to do shunt mixing at the input side, I'm going to reduce my input resistance. Only two cases. And output side I am not bothered. Output side you use voltage sampling or current sampling, whatever you use, I don't bother. I am more bothered about what we do at the input side or what we do in the mixing network. If the mixing circuit is going to use series mixing, then the input resistance is going to increase. If the mixing circuit is going to use shunt mixing, the input resistance is going to decrease. How much it is increasing? So it is the original value of resistance into 1 plus A beta. You know, 1 plus A beta is called as D sensitivity, capital D. How much it is going to reduce? Same amount divided by 1 plus A beta, so RI by D. And D is again called as D sensitivity.